Today we'll be talking about phase difference. So before that, let's try to look at this water droplet experiment again, where the waves on this water are traveling away from the source of the droplets. So I place this water level measuring device. I just call it oscilloscope for simpler reference. Yeah. So this oscilloscope has two readout. Okay, I actually have placed them together at this position here. Okay, at this position here, so that you can see on this oscilloscope screen, it has the displacement shown on the screen, going up and down according to the displacement of the water. So what happens if I start to move one of the readout away? Then you can see that they split into two graphs. So this two graph actually showing you the movement of the water molecule at that particular position. Okay, and now you can see that they are crossing each other. So when I place them together, they are the same. Okay, so this kind of situation we call them in phase. Okay, we call them in phase. They have no difference in their parts of the oscillation. So now I'm going to freeze the diagram. Okay, and then I move these two to two identical peaks. Okay, so to two identical peaks, and then I run it again. Okay, so you can also see that basically they have no difference. It's just about their amplitude because it has dissipated some energy. So basically they have no difference. Okay, we call this kind of oscillation again in phase because they overlaps. So if I move it to another position, which is a bit further away, again it's a similar identical peak. So it also show me in phase. Okay, a bit away, but never mind. Okay, the idea is these two water molecules on the wave are actually in phase. Their oscillation are actually in phase. So at other position where I randomly pick, and you can see the graph, they are not overlapped on each other as shown in the oscilloscope screen there. Then we call that kind of situation as out phase. Okay. So now we're going to go into a little bit more detail on the idea of phase difference in terms of some numbers. Okay, so phase difference basically can be expressed in two units. One is called the radian, and the other one is called the degree. So 360 degree, we know that is for one cycle. So in terms of oscillation, is one complete oscillation. And also for radian, in maths you already learned that 2 pi radian is for one circle, right? So in terms of oscillation is one complete oscillation. So 2 pi is one complete oscillation. So if two of the water molecule they are in phase, we can see that their oscillation is like synchronous. Then we say that they have zero phase difference, zero radian phase difference, or 0 degrees phase difference. So we're going to look at another situation where they have half a cycle that they are ahead or behind each other. So to demonstrate that, I'm going to move one of these readout at a peak, and I'm going to move the other one to a trough. Okay, to a trough, its lowest position. Okay, so that they are going to show us the case of half a cycle difference. Half a cycle difference, if you divide by 2 pi, that will be a pi radian. If you divide it using the 360 degrees, then it will be 180 degrees of the phase difference. So you can see the graph crisscross like that. When one is at the peak, the other one is at the trough. When one is at 2 cm at the positive side, the other one will be at the 2 cm on the negative side. So that is half a cycle in terms of their phase difference. So what happens if I now switch to a position where they show us quarter of cycle in the difference of their oscillation. So quarter of the cycle, I need to use a measuring tape first. So just now it was about let's say, let's make it 1.4, that will be easier for us. Then 1.4 is this half cycle, right? So half of the half, that will be about 0.7. Okay, 0.7, so I'm 0.6 now. Okay, 0.7 can. So I just move it slightly here as a reference. If not, then I don't know where to put. Okay, so this one will be like quarter of a cycle of this wave. And then we can see that they almost run parallelly. Okay, and then you can see their peak, the two peak on this CRO screen here, they are very close to each other, but they are not really overlap, and they are not like one on peak and one on trough compared to just now. So they are like a parallel wave going together. Okay, so this case is actually quarter of an oscillation.